Hello guys, welcome back to Maison African Motives, working on mathematics for grade 11. In this case, we are going to be focusing on functions revision from the question paper of November 2019. That was November 2019. Okay, so we have got here November 2019. Okay, that's the question that you're going to be working on. Question number 5, which was actually on a hyperbola. So we are given f of x is equal to 1 over x minus 3 minus 2x plus 6 over x plus 3. 5.1, show that f of x can be written as f of x is equal to 1 over x minus 3 minus 2. Okay, what is it that is happening here that we are going to do so that we can have this in this format? Okay, so here I'm just going to utilize this space here. That's 5.1. If you are to check here on your f of x, you can actually factor out on the other part. There is 2, which is common. So we've got 2 here in 3, 2. That is common in both numbers. The 2 is common in these two numbers, the 6 and the 2. So if we factor out the 2, that means we can be able to divide this. If we factor out 2 here, that's simply dividing 2x divided by 2, which means we are going to remain with x. 6 divided by 2, which means we are going to remain with a 3. Okay, everything here is over x plus 3. So as we can see, these two are the same. So we can actually cancel. That's having our f of x in the format that we are given. So our f of x is going to be 1 over x minus 3 minus 2, this part that cancelled. So this is going to give us a negative 2. All right, so that is what you're just asked to show. 2 marks for that. Okay, 5.2, write down the equation of the asymptotes of f. So take note on a hyperbola that if you are given this f of x in this format, let me just have my f of x. It's actually, I need to work it from this side. All right, so take note before that our f of x, we simplify this and we got x minus 3 minus 2. So the asymptotes, they are simply taken from the x values. We equate this to 0 so that you can have the value of x. So x minus 3 is equal to 0. So x at there is going to be 3 at the asymptote, and y is equal to the value of minus 2 that you're given direct there. So y is equal to negative 2 in this case for the asymptote. All right, so y is at negative 2, x is at positive 3 in that case. All right, so that was our question for 5.2. Determine on 5.3, we are now given to determine the x-intercept of f, and that is 3 marks for that. So remember that the x-intercept is always when y is equal to 0. So you can take advantage of that to say the x-intercept is at y is equal to 0 in this case. So this is at y is equal to 0. So if y is equal to 0, you can substitute in place of f of x, which represents y. So this is 0 is equal to 1 over x minus 3. So that's 1 over x minus 3 minus 2 like this. So you can be able to calculate for x from this part. Okay, so what can we do to calculate for x? Can transpose the negative 2 to the other side so that it can be a positive. So that's 2 is equal to 1 over x minus 3. So 2 is a whole number as a fraction, same as over 1. So in order for you to find x, you can simply cross multiply in this case. So this is 2 times x, which is going to be 2x, 2 times negative 3, which is negative 6, which is equal to 1 times 1. Take note, 1 times 1, which is 1. So you can be able to calculate the value of x by transposing negative 6 to the other part of the equation so that it can be a plus. So that means 2x is equal to 1 plus 6, which is a 7. So to find x, simply divide by 2 both sides. So x is equal to 7 over 2 in this case. So this is the value of x that you're going to obtain, 7 over 2. Or we can actually have this as a decimal. So as a decimal, 7 over 2, that is 3,5. Okay, so that is the value of x, which simply means that at the x-intercept, x is equal to 7 over 2, y is equal to 0. Remember, a point is made up by x and y, and we said for this x-intercept that we got here, y is equal to 0 for the x-intercept. All right, so that was the case here. If we are to check on the other part, that is 5.4, determine the y-intercept of f, and that is 2 marks for that. So the y-intercept that's x is equal to 0. So this is just a continuation. We can simply take from our f of x here. This is our f of x. I can just write it aside here. We can just utilize this space here. So that is 5.4. So we are saying that for the y-intercept, x must be equal to 0. So if x is equal to 0, you can simply substitute in place of x here. That's y is equal to 1 over, in place of x, that's a 0. So that's 0 minus 3 minus 2. Okay, so this we can just simplify from a calculator. That's 1 over minus 3 minus 2, which is going to give us the value of y, which is a negative, so this is going to give us negative 7 over 3. So you're going to obtain negative 7 over 3, of which is a decimal. That is something like negative 2,333 and so on. Okay, so this is the value of y that you're going to have. So remember, a point, like I said, that's xy, and x at this point is a 0, and y is minus 7 over 3. So this is going to be our y-intercept in this case. All right, so we have the y-intercept. Then from there, determine, okay, 5.5. We are now on 5.5, where now we are to sketch this graph. Okay, so sketch the graph of f, show all the intercepts with the axis and the asymptotes. All right, so there we are supposed to show, okay, the one of the asymptotes. All right, so we are supposed to show the axis, the intercepts with the axis, and the asymptotes. Okay, so the first thing, when you are to sketch a hyperbola, take note, whenever you are dealing or you are working with a hyperbola, the first thing is to indicate or to show the asymptotes. That's where your graph is limited to. So we must know where our graph is limited to. All right, so this is what we have, all the information we have on this part here. We've got our x-intercepts. We calculated our x-intercept, this point, the y-intercept, and also the asymptotes at x is equal to 3, y is equal to minus 2. So this information is actually enough for us to sketch our graph. All right, so here we shall have our x and y axis. Okay, let's just have a sketch. So this is just a sketch, guys, that I'm going to have here. So I shall just have my vertical line and my horizontal line in this case. Sorry for that, for having this ugly line, but that's how we are going to have here. That's why here. So we're gonna have our values. Let's just say 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4, negative 1, negative 2, negative 3, negative 4. You're gonna have 1, 2, 3, and 4. All right, so let's start with the asymptote. That's the first thing that you're supposed to indicate whenever you're dealing with the hyperbola. The asymptotes, that is at x is equal to 3 and y, which is equal to negative 2 in this case. So x is equal to 3 and y is equal to negative 2. Okay, x is equal to 3. That's x is equal to 3. We go straight at x is equal to 3 here. That's the value of x, which is 3. So we shall have our asymptote here at x is equal to 3. So we can just have even in terms of broken line, or we can just have a continuous line just to indicate this. Okay, so that's a vertical line there. X is equal to 3. Then another one was what? Y is equal to negative 2. Y is equal to negative 2. That is somewhere here. So pardon my sketch, guys. It's not that perfect, but this is what you're supposed to have. All right, so this is your other asymptote, which is at y is equal to minus 2, direct where y is negative 2, like that. Okay, so this is what you're going to have in this case. So with the asymptotes that we have, take note here, we are limited for these asymptotes to say our graph is not going to pass these asymptotes. And also we need to know the shape. The shape is taken from the a that we have here from our function. If you check here from this function, this is a positive. That's 1 over x minus 3. So when it is a positive, it means you shall have a shape like this and another piece in the other quadrant. Okay, that's actually taken from the first and the third quadrant. If it is a negative, then we shall have it in this quadrant and in this quadrant for a negative value. But for a positive, that's this quadrant and this quadrant. So meaning to say, we are supposed to check where our x-intercept is. our x-intercept is at 3,5, which is 7/2. So this is where our x-intercept is. So we are limited to, we are going to mark 3,5 or 7/2. 3,5 x-intercept is somewhere here. So this is where we can just have our 3,5. So our graph is going to be in this quadrant like this, but limited at -2 for y. So meaning to say we shall have a graph as it approaches to x is equal to 3 to this point, our x-intercept at this point, and it tends to be approaching -2, but it will never meet this line. So this is the piece that you're going to have on this side. So that's passing the x-intercept at 7/2 or 3,5. So this is our x-intercept here. All right, then we move on to the y-intercept, which is at -7/3. -7/3, like I said, this is something like -2,33. Okay, so y-intercept is in the negative region. So this is where we shall have our y-intercept in the negative region. That's somewhere here. -2, somewhere just here, -2, something. So we shall have in the y-intercept this region as it is going to meet, this point at this point here. So yeah, we are supposed to meet this point, and it is going to be approaching the line of x is equal to 3, but it won't reach this line. It won't be able to reach line because that's an asymptote, and also it won't be able to cross the line of y is equal to -2 because that's an asymptote. All right, so this is our curve for f. So you can just indicate f on this side, or you can indicate f on the other side of the equation, of the function, any part. So this is how we can be able to sketch a hyperbola in this case. What you note is you are limited by the asymptotes. The asymptotes are the ones that limit you. So this is the first thing that you're supposed to indicate. That is the asymptote. Okay, that was our question 5.5. Let's check the other part of the question here, which is on 5.6. All right, it's 5.6, which is to determine the equation of the axis of symmetry of F. Take note, the axis of symmetry of F that is having a positive gradient, because there are two equations that we expect for the axis of symmetry. So that is why they have to mention which one is it that we are going to use, the one that has got a positive gradient in this. So this whole part is on the formulation. Okay, so when you are giving a positive gradient, that means our line is supposed to be in this form. That's a positive gradient in this case. But for the axis of symmetry, it's a special type of equation that you're supposed to have. Okay, let me show you where on our graph here. This is our graph. Okay, so what happens with the axis of symmetry is that it passes through the point of intersection of the asymptotes. This is our asymptotes here. So the line is going to pass through this like this. All right, let me do this way, like this. This is the one that has got positive gradient, and the other one that has got negative gradient is going to be like this. So these two lines, they are all limited at the point of intersection, or at the coordinate where we have the x value for the asymptote and the y value of the asymptote. So meaning to say we can be able to determine the gradient, or the equation of this, since our equation is given in this format. Okay, for the one that has got a positive gradient, y is equal to x plus c. Always, there is no other part that you're going to have. This is always a positive x, when which is a positive 1x when it is for the positive. For the negative, it's y is equal to minus x. So y is equal to minus x plus c for a negative. So these are the formats that you need to use. Okay, but on both conditions, they are passing through the asymptotes, meaning to say we are given a point here where x is equal to 3 and y is equal to -2. Remember those values that we got before at the asymptotes, x is equal to 3 and y is equal to -2. So these are the points. This is the point that you are going to substitute here, 3 and -2. So meaning to say We have the value of x and the value of y. Y is -2. So -2 is equal to x, which is 3 plus c. So we can be able to calculate c, transpose 3 to the other part. -2, -3 is equal to c. So c is equal to -5. Okay, so if c is equal to -5, that means our equation, therefore, is y is equal to, from our normal equation that we had here, which is x plus c. So it's x, always like that, x. So this is going to be x plus c, our c, which is -5. All right, so this gives us the equation of the one that has got a positive gradient. If they said the one that has got a negative gradient, meaning to say your equation was going to be formulated from this format. All right, so that was our question 5.6. We move on to question 5.7, which is another part of the question we still have a lot. That is 5.7. The graph of f is transformed to obtain the graph of hx, which is 1 over x. Describe the transformation of h to x. Okay, of f to h. So what you simply need here is, before, remember our f of x, this is our f of x, 1 over x minus 3 minus 2. So you simply have to ask yourself, what happened from that f of x to obtain this h? All right, so let me write our original f of x here. So remember that originally our f of x was given as 1 over x minus 3 minus 2. Now they are saying, we transformed this graph of f to h. So this is f to h, where h is now given as hx here, which is 1 over x. So what happened? We were having a -3. Now we do not have, which means here it's like there is a +0. We were having a -2 here, but we don't have, which means we are having like a +0, which means what actually happened? So you're simply asking yourself, what happened on x here in order for us to obtain a 0 from -3? It simply means that here we added a 3. X minus 3, the one that we have here. If we add a 3 like this, -3 plus 3, that's a 0. So adding 3 on x, which means we are talking about this transformation written as f of x plus 3 like this. A transformation of f of x plus 3, which is taken from the transformation of f of x plus a. That means it's here, we are talking about moving a units to the left. It's a positive here on the presentation, but this means it's a units to the left. We have moved a units to the left. So adding a 3 means that we moved 3 units to the left. That is the one that made us to obtain a 0, because -3 plus 3, that's a 0, meaning to say we are just having 1 over x. So meaning the first transformation was of +3, added 3. And we're saying a plus from f of x plus, say, is a shift of a units to the left. So the first transformation was a shift of 3 units. So that is 3 units to the left. All right, so this is the first transformation that occurred. 3 units to the left. Then we move on to the other part. Here, previously, it was -2. Now it's a 0. So what happened? We added a 2 again. -2 plus 2, that's a 0. But on y, to add a term, to add a on f of x like this, if we are saying f of x plus a like this is a shift of a units upwards. So this is going up. So it's a units upwards. We are adding, we take as it is. So this +2 that we added, it means it's a shift. So this one is going to be a shift of 2 units up. So this is 2 units up, which is 2 units upwards, or just 2 units up. So these are the transformations which actually occurred from the f to h. We added 3, that is to give us a 0. We added 2 to get a 0, but that, how are we describing the transformation? That is the most important part. Okay, on 5.8, we are now given 5.8, write down the domain of h. The domain of h. Remember, h is given here. Hx is 1 over x. So now we are asked to find the domain. Okay, so that is a 5.8. How do you find the domain there? Okay, 5.8. Remember, our hx is given with 1 over x. So the domain, we are talking about the values of x, the limiting values of x. So we know that our x in the denominator can never be equal to 0. We can't have our denominator equal to 0. So that means our x here can be any number that you think, any real term that you think of, but it cannot be a 0. So we can conclude that our domain is values, all values of x, but x cannot be equal to 0. But x being all the element of real terms or real numbers that you're going to have, or we can actually take our x as, since it is consisting of all values, x can be any value. That means x can be taken from negative infinity up to positive infinity, but on a condition. One condition is that this x can never be equal to 0. Remember, denominator cannot be equal to 0. There is no 2 over 0. This one, it approximates infinity. It's actually undefined. So for our level, we're saying this is actually undefined. 3 over 0, that's undefined. So that's why we are saying our denominator cannot be equal to 0, because the expression will be undefined. Okay, so these are the typical questions, guys. As you can see, that's 5.8, which is the last part of the question, having a total of 19 marks. So this is how you're supposed to expect your questions to be like on functions on a hyperbola. They can give us something of this nature. We just have to play around the questions and see. As we do more questions, then we'll know how do they ask these typical questions. But for now, that's it, guys, from Meson African Motives. Till we meet again.